Hello, everyone. Welcome to today's live broadcast, Lab Sustainability, Keeping the Planet and Your Wallet Green. I'm Judy O'Rourke of LabRoots, and I'll be your moderator for today's event. We are delighted to bring you this educational web seminar presented by LabRoots and sponsored by Eppendorf. Eppendorf is a leading life science company that develops and sells instruments, consumables, and services for liquid sample and cell handling performed in laboratories around the globe. For more information, please visit eppendorf.com. We have a few important announcements before we begin. This webcast is designed to be interactive, and we encourage you to ask questions during the event. You can submit questions by typing them in the Q&A box, which can be found by clicking on the green Q&A button at the lower left of the presentation window. We'll try to answer as many questions as we can. You can enlarge the slide window by clicking on the screen icon in the lower right-hand corner of the slide window. If you have any technical problems viewing or hearing the presentation, please click on the support button at the top right of your presentation window or submit your problem through the green Q&A button, lower left. I would now like to introduce today's speaker, Daniela Marino, Product Manager of ULT Freezers and New Brunswick Shakers at Eppendorf, North America. I will now turn it over to Daniela for her presentation.
Thank you, Judy, for the introduction, and thank you, everyone, for joining me on today's webinar with a focus on sustainability solutions for the lab. As technology advances and globalization develops, our way of life has become more dependent on energy sources to power our everyday activities. The energy we use in our everyday life generates the majority of greenhouse gases in the form of CO2 emissions, which is responsible for increasing our carbon footprint. CO2 emissions have a wearing effect on our atmosphere, resulting in environmental changes that may become detrimental to human life in the future. Ironically, the same lab that we are studying the effects of CO2 on our atmosphere, or the lab that is looking for the cure for cancer to improve human living conditions, is also consuming the most energy. A typical laboratory setting has many items that are consumed on a regular basis, from energy to labware such as plastic tubes and plates. Many of us do not realize there is room for significant improvement in our daily or annual processes to reduce consumption in the lab and offer a more sustainable solution. On university campuses today, laboratory space takes up about a quarter of the campus. However, these labs are responsible for consuming about half of the total energy. Today's webinar is going to focus on the general products that can be found in the lab and how we can choose, maintain, and dispose of these instruments while reducing cost, waste, and energy consumption. Our overall goal is to decrease our carbon footprint, educate researchers and everyone who is a part of our global community about sustainable solutions, and to offer peace of mind for future generations. There are many opportunities to reduce our carbon footprint while still optimizing science, which is what we will talk about today. The first product we are going to address are fume hoods. Fume hoods are one of the most important safety features to be found in the lab. However, they consume more energy than anything else. They are responsible for consuming about 3 to 3.5 times the amount of energy needed to run the average American household. Energy is consumed by the fan motor that pulls the air through the front of the hood and out of the stack. Energy is also consumed in order to heat, cool, humidify, or dehumidify that volume of air that is being discharged into the atmosphere. If the sash is left open, a fume hood can start to cost upwards of $5,000 a year to operate. So what can we do to reduce the energy consumption here? One important and easy thing to do is to shut the fume hood sash. Shutting the sash will reduce the volume of air being drawn through the hood, even on single-speed drive hoods. Next, reducing obstructions in the fume hood improve the efficiency by allowing adequate airflow across the working surface with minimum turbulence. It is also important to keep fume hoods clear of unnecessary items that can block ventilation. Next, when purchasing new equipment, explore efficient options. Some fume hoods are designed to be energy efficient without additional measures, such as ductless fume hoods and high-performance fume hoods that operate at lower phase velocities. With newer variable speed dry hoods, the air volume can be reduced from 60 to 80% when the sash is closed, which results in incredible energy savings. Second to fume hoods, ultra-low temperature freezers, or ULT freezers, are the second biggest energy suckers in the lab. On average, a typical upright ultra-low temperature freezer consumes about 0.85 kilowatt hours per day per cubic foot in a laboratory setting. As most upright freezers are on average about 25 cubic feet, this means they are consuming about 21.25 kilowatt hours per day. This is about the same energy needed to run the average American household. On average, every lab has between 2 and 3 ULT freezers here in the U.S. To give some perspective, there is an estimated 58,000 ULTs to be found in California alone. When crunching the numbers, this means that ULTs in California alone consume 1.2 million kilowatt hours per day, which adds up to 937 tons of CO2 emissions that we're putting into our atmosphere. If we take anything away from these numbers, it should be that there is a significant room for improvement to have a more sustainable approach for long-term sample storage in ultra-low temperature freezers. So what can we do here to make efforts towards efficient solutions? When purchasing new freezers, it's important to get information on the energy consumption of that freezer. Also, look for products that have low heat output. This will indirectly reduce the energy consumption by reducing the size AC unit needed to cool down the ambient temperature where the freezers are located. Also, when comparing these specifications, it is important to know that you are not comparing apples to apples between different manufacturers. Always ask about how the efficiency specifications were achieved. It is also important to inquire about performance as well, considering very precious samples are continuously being stored in these ultra-low freezers. Now, the most efficient ULT would be the ULT that's not even plugged in. But what good would that be? We need to also make sure it holds the temperature that we need, recovers the temperature that we need, and keeps our samples safe. There is no room for compromising performance. As a community, we are working towards a standard for testing. However, right now, the best way to compare performance of a ULT is by comparing the pull-down times from ambient to set temperature. This is the most stressful activity of an ultra-low that it has to perform and is the most standardized way to compare various models. High-quality materials and design are also very important. Many may see an ultra-low as a box that gets cold, but the material, particularly the outer door gasket, is very important to take notice to for efficiency, performance, and product longevity. The outer door gasket on any ULT is the most vulnerable place on the freezer to lose cold air. Often, ice builds up on these gaskets. As ice builds up, the integrity of your seal decreases, resulting in an increase in cold air loss. This increases the compressors running and decreases the performance and efficiency. Therefore, it is additionally recommended to clear ice buildup on the seals and inspect all seals and gaskets routinely. This effort leads us to routine maintenance. Similar to your car and how you need to regularly get oil changes, an ultra-low needs some maintenance to run efficiently. Over the lifetime of a ULT freezer, the energy consumption required to run the system will increase. These efforts will keep your freezer running optimally. Check gaskets and rubber seals around the freezer door and clear away any ice buildup with a soft cloth or rubber ice scraper. Be cautious to avoid damaging rubber seals. Next, clean the filter that protects the condenser coils. Often for uprights, this will be found on the bottom of the freezer, and this will allow for proper air circulation and cooling. Always perform annual cleanouts, defrosting, and inventory checks. Once ice buildup gets to about 3/8 of an inch, empty the freezer to do a manual defrost. During this process, evaluate what samples are being stored within the freezer. It is okay to get rid of samples, especially those which are not labeled, may be expired, or belong to researchers who no longer work there. This will leave room for other samples and make them easier to find, essentially also reducing the time before you need to purchase another freezer for sample storage. Take notice to your freezer's performance over time. There are some signs to look for, such as when a freezer has a pattern of being slow to recover or cannot keep temperature, temperature uniformity within the chamber is outside the manufacturer's specifications. When you hear the compressor running constantly, this is indicative that the compressor is running overtime. When you feel a lot of heat coming off of the freezer, or the ambient temperature of the room is increasing, and also when there are signs of heavy frost affecting the ability of the door to have a good seal. These are all signs that indicate that it might be time to maintain or have a check of your freezer to make sure that it's really running under optimal conditions for optimal efficiency. Being green matters most when you don't notice it. Now, it may be obvious that the very large equipment in the lab are the products that consume the most energy, such as our fume hoods or ultra-low temperature freezers. But what about all the other items in the lab that are plugged in or consumed? Everything from microcentrifuges to thermal cyclers, your heat block or electronic pipettes are consuming energy. In some instances, you may not even realize how much energy they actually consume. Starting with thermal cyclers. Thermal cyclers need to precisely manage high temperatures across a block to ensure accurate and reproducible amplification of nucleic acids. Often these products run all day, consuming energy at all hours. So what can we do here to make an effort towards choosing an efficient approach? Look for equipment that has shorter run times. If you are able to reduce a PCR run from 4 hours to 3 hours, you are now eliminating 1 hour of energy needed to control the temperature on the block, essentially saving energy. There are a few technologies available that provide faster run times. Also, look for equipment that has a standby mode to reduce energy consumption when the product is not in use, but may need to be turned on and warmed up that day. Also, if you need to run multiple blocks, check for the capability to hook up to a satellite system. This allows you to use just one control center to manage multiple cycler blocks. The less control panels or centers you use, the less energy you need to manage the blocks, also reducing overall energy consumption. Additionally, something to think about is if there is a technology that supports you using less reagents. Bubble allows you to use a smaller sample size without having to worry about evaporation. The smaller the sample size, the less reagents you use, directly correlating to waste during PCR. The graph we have here shows the power consumption of a typical PCR run for various different models of thermal cyclers that are available to researchers today. Whereas the kilowatt-hour usage seems much lower than those of a ULT freezer or fume hood, these numbers can really add up quickly, especially when multiple runs are done in a day and when there are multiple PCR machines. There are usually about 2 cyclers per lab and about 3 runs per day per cycler. If you choose the right cycler, you can reduce your energy consumption significantly. Now, here we can see that we have a few different manufacturers have the options of a standby mode. This allows the machine to be plugged in, but consumes significantly less energy while also being ready to be warmed up quickly. This is a great feature to look for when purchasing a new cycler. However, be aware that many of the units which have a standby mode are still using energy. and some significantly more than others. Another recommendation would be to actually unplug all equipment when not in use to avoid energy consumption while a machine is assumedly turned off. Refrigerated centrifuges are a staple in any lab setting. Often, there is a 1-to-1 ratio of refrigerated microcentrifuges to personnel in the lab. So what can we do here to improve efficiency and sustainability when looking for a new centrifuge? Look for programmability options for cooling. Oftentimes, researchers may turn on a refrigerated centrifuge to cool overnight, so that when they get in the morning, the centrifuge is at a set temperature, usually around 4 degrees Celsius, and they can start working. As you can imagine, this process can consume a lot of energy. There are technologies out there that allow you to program your centrifuge similar to your coffee maker to turn on and start cooling at a particular time on a particular day. These programmability features can save up to 80% of energy consumption, which is a huge savings. You can also look for centrifuges that have faster pull-down time to set temperature. The quicker a centrifuge can pull down to the temperature, the less energy it needs to consume. For instance, if the refrigeration system needs to take 40 minutes to get down to a 4-degree set temperature versus 8 minutes, you're saving 32 minutes of the compressor's running time, essentially reducing your overall energy consumption. Similarly to the PCR machines, some centrifuges may also have the capability of being put into a standby mode or even automatically turn off after hours of non-use. These features alone can result in a 50% energy savings per centrifuge. Which brings us to our next point, making sure the centrifuge, just like any other product, is made of quality materials and construction. Now, there are many different types of centrifuges on the market, all made with a variety of purposes. However, for centrifuges used to spin at high G-forces or spin hazardous materials, it is a misconception that the product lifetime of a centrifuge is 6 months to 2 years. Your centrifuge should last much longer than that, anywhere from at least 5 to 7 years or maybe even longer. This will significantly reduce waste we see from the lab. Additionally, the construction of the accessories, such as the rotors, can also open an opportunity to have a more sustainable lab. Many rotors now are made to be lighter, which helps reduce the energy needed from the centrifuge to spin that rotor and your samples at such high speeds. Also, many rotors are also made to be 100% recyclable. Consumables are plasticware found in the lab such as tubes, plates, flasks, beakers, and many others are used in everyday lab settings. These items are generally used once and thrown away for reasons such as contamination and convenience. Therefore, there are a few small things we can do to make significant strides towards our sustainable lab. Choose products that are properly marked with codes to be recycled. If they are not marked, you cannot recycle them and reduce a significant amount of waste. Choose products that do not use harmful toxins in the manufacturing process. Not only is this making a conscious effort to choose a sustainable product, but these toxins can also contaminate your sample, skewing your results in downstream applications. This will also lead to excessive waste of consumables and samples. Many times, we often use a 15 or 50 ml tube to store our samples. However, many times we are not actually putting that much volume into our tube. Look for tubes of smaller size to store your samples in, if possible. This will reduce the amount of plastic waste, but also reduce the amount of space needed to store these tubes. If you are putting these into an ultra-low temperature freezer for long-term storage, you can store almost double the amount of samples if you choose a smaller vessel. Also, we do not need to always use plastic. We can still choose to use glass for applications such as cell growth in flasks, which will also significantly reduce waste. Automation liquid handlers are more commonly being used for sample preparation. Using liquid handling automation has the utmost precision and accuracy, which optimizes the remaining volumes in any lab vessel, eliminating waste. Also, with the precision and accuracy we see with these systems, we are able to use less reagents and smaller samples, which reduce waste as well. Additionally, due to the programmability, you can choose when tips are disposed of. This, plus the ability to reload your tips, can reduce plastic waste in these systems by up to 40%. Reducing water waste is also a big topic of discussion when striving for a sustainable lab. Instruments such as heat blocks or dry incubation systems eliminate the need for water and also reduce the energy needed to heat or cool your samples. Heat-shielded blocks also reduces the amount of energy needed to keep your blocks at set temperatures. Direct heat technology, found in CO2 incubators now, offer a more sustainable alternative to water-jacketed systems, which required a significant amount of water to surround the incubator for temperature management. So just a few small things here that can reduce water waste. Whereas the effects are not always tangible, it is hard for some to justify making changes to the daily routine of purchasing or maintaining equipment. The biotechnology industry has now recognized its role in this global initiative and has focused on improving laboratory products to reduce energy consumption without depriving functionality or reproducibility. So, in summary, we have a ton of tips to help reach our goal of having a sustainable lab. In review, when choosing new lab equipment, remember to look at the energy consumption of that product. Think about if it is a product that is used essentially 24 hours a day, or if it is a product that is used sporadically, as instruments used more often will offer the biggest value in reducing energy consumption. Are there any special features, such as programmability or a standby mode, that will additionally help in the efforts to reduce energy consumption while the products are plugged in? Make sure you also choose a quality product that will last, and in doing so, make sure no specifications are compromised by choosing an efficient design. Science still needs to be accurate and reproducible, and choosing a quality product will help with those efforts. Additionally, make sure you are covered by warranty, especially on parts of your equipment that may affect the efficiency of that product. Maintaining lab equipment properly ensures efficiency and product longevity. This comes back to the statement of choosing quality products for the lab that will last a long time or that may have another life in another lab setting. Make sure everyone is educated on the best practices for maintaining the products in the lab and knowing when to schedule a service or preventative maintenance. Lastly, properly disposing or recycling your products at the end of their life in a particular lab setting can significantly reduce waste. Make sure products are properly marked for easy recycling. And ask facilities or your local sales representative about recycling programs, which will help in the removal, recycle, and disposal of old or damaged products. Reducing energy consumption of the products in the lab puts green in your wallet too. By choosing efficient lab equipment and properly maintaining current lab equipment, you will significantly reduce our carbon footprint, but also reduce the amount of money spent on your electric bill. You can save thousands per lab by making just these small efforts. Reducing energy consumption saves money, saves our planet, and saves our quality of life for us today and for future generations. Lastly, education is key. We are always learning new ways to make significant improvements to our everyday routines. Many manufacturers of lab equipment, university groups, and researchers keep finding new ways to keep our blue planet green while keeping the green in your pocket. Please feel free to reach out or ask questions or make comments. At this time, I would like to thank you all for joining me on this portion of the presentation.
Thank you for that informative presentation. Before we get started on the question and answer session, I'd like to remind our audience how to submit questions. You can submit questions by typing them in the Q&A box, which can be found by clicking on the green Q&A button at the lower left of the presentation window. We'll try to answer as many questions as we can. Also, the slides are available for download in a PDF version on the lower left of your screen. Okay, the question is, what are your thoughts on keeping your ULT freezer at minus 70 degrees versus minus 80 degrees?
That's a very good question. Many are moving towards keeping their freezer at minus 70 versus minus 80, and we do see significant reductions in energy consumption at running our freezers at these temperatures. However, it is important to consider the biologics that are being put inside these freezers. Minus 70 might not be a suitable temperature for some samples, and so we don't want to compromise the integrity of our samples, so we just need to choose wisely on when we set certain freezers at certain temperatures.
Great. Is it more efficient to purchase the largest capacity ULT available?
Overall, large freezers will have a lower energy consumption per cubic foot. However, when it comes to security and backing up a freezer, often if you pick the largest freezer available, it may be difficult to back up that freezer when necessary. So again, it really is a balance of choosing an efficient design but without compromising the security of your freezer setup.
Okay. If there are no more questions, I would once again like to thank Daniela Marino for her presentation. Do you have any final comments, Daniela?
At this time, I would just like to thank everyone for their time today. For additional information, please feel free to review this webinar, which is available via PDF. Feel free to visit our website or contact myself or your local sales representative for more information.
I would also like to thank our sponsor, Eppendorf, for making today's educational webcast possible. Today's webcast will be available for on-demand viewing through March 17, 2016. You will receive an email from LabRoots alerting you when this webcast will be available for replay. We invite you to forward that announcement to your colleagues who may have missed today's live event. See you next time. Goodbye.